Hello, greetings of the day. I am Kamal Agarwal. I am a student at BITS Pilani. I am here to present my research work, Replication Based Fault Tolerance for Cloud, at 18th ICDCIT conference. And the co-author for this work is Dr. Babu. He is an assistant professor at Department of Computer Science at BITS Pilani. Here, I am going to present how we can use replication-based approaches for providing fault tolerance in cloud environment. This is the outline for this presentation. Introduction, and then some related works. Based on those, I have formed my problem. Then proposed algorithm, simulation setup, results, and conclusion. Coming on to introduction, cloud computing, which has been characterized by multi-tenancy based model, and it is in trend in academia as well as in industry, and it has become an integral part of current IT infrastructure. This makes it to have a reliability a crucial part of it. A cloud infrastructure is distributed in nature and has many different components. Interaction among these components brings in complexity as well as chances of failures. That's where fault tolerance approaches are needed. The main few reasons of the faults include software failures such as incorrect upgrades, excessive workloads, or there may be hardware failures such as unavailable resources, network failures, etc. Major type of faults are network faults, physical faults, service expiry fault, ordering faults, and in literature there are some other faults also such as parametric faults. One important thing we need to consider is that as it is a distributor system, it brings in many aspects of environment. Faults in the system can occur in any part of the system. And while designing fault tolerance approaches, we need to consider each component as well as whole system. The cloud computing, as it is a distributed system, it has been characterized by partial failures instead of complete breakdown. And fault tolerance is the ability of system to continue its operation regardless of faults and recover from these faults. Currently, fault tolerance approaches discussed in literature is of mainly two types: reactive approaches and proactive approaches. Reactive approaches reacts to the failures, which means they have their action after the failures have occurred. They try to recover the system from failures. As opposed to proactive approaches, they try to avoid failures by taking sufficient action beforehand. Now there is one more approach known as resilient approach, which is based on machine learning and AI, which can be found in literature. Some of the reactive approaches are checkpointing, job migration, replication, retry, and resubmissions. Checkpointing system or process states are saved periodically to recover the system after failures. Job migration, if a failures occur, a request being executed or a service being executed is moved to another host for further execution. Replication, in replication based approaches, either the jobs or the request, all the things are replicated for further execution. Retry In the retry, job after failing to execute will be retried on the same host for further execution until it completes its execution. Resubmission based approaches, a failed job will be resubmitted to same or maybe or another host for further execution. Some proactive approaches are self-healing, software rejuvenation, preemptive migrations, and load balancing. Self-healing approaches uses divide and conquer techniques. They distribute actual computing work among different instances to handle faults automatically without interference from administration. Software rejuvenation, the system undergoes periodic reboots and begins from a new state. This overcomes any minor faults and failure that have been occurred in the system and missed out from admin. Preemptive migration uses a feedback-based loop to analyze application state and detect any faults to avoid failures. Load balancing based approaches uses balancing of load to overcome the failures. Some of the related works. So in early phases of the cloud, fault tolerance approaches were not used due to its greater overhead. And currently also replication and checkpointing are the most commonly used and heavily researched among researchers. One of the reactive approaches is random selection VM placement, in which after creation, VMs will be placed on randomly selected host, but whenever a fault occurs, data required will be refaced. RLVMP. This one also focuses on placement of VM in particular host. So in RLVMP based approach, a copy of data will be stored on the same host to reduce the network resource consumptions due to the refetching of data. In OPVMP, it uses three-step methodology in which first step includes selection of host server, second step is optimal VM placement of VM, and third step is to formulate a strategy to recover from failures and minimize network resource consumption, and it is based on fad-free topology. VFT, redundancy and checkpointing, uses software variants on several machines. Machines here are VMs, and also tries to minimize future faults by not assigning jobs to VM that have already faced faults. One of the proposed solution is prediction planning based approach. Method of recovery from replication and retry is selected for recovery depending upon the failure history, user requirements, and criticality of the task. One another presented method is based on both resubmission and replication. Selection of appropriate method will depend upon the priority of the task, task length, deadline, and out degree of the task. If we try to analyze all these approaches, we will find that RSVMP, it requires the refetching of the data, so results in increased network resource consumptions. OPVMP, it focuses only on fad-free topology. Using software variants results in increased complexity and increased testing efforts. One of the presented work depends on the task parameter only, such as priority, out degree, deadline, but doesn't consider infrastructure parameter. Checkpointing based algorithms are not storage efficient, as they don't consider the probability of any VM or host failures. Replication based strategy uses method where replication of all the VM has been done, which is not an economical thing. We need to consider some other factors also. Moving on to problem description. Problem with replication based approach is that replicating every VM is not economical, as if we could allocate other requests to these extra VMs. So we should replicate only a subset of available VMs. So how should we identify them? We can think of VM who already faced some faults as fault prone and consider them only for further replication. And also the VMs to be created on that host to be more fragile. Apart from this, we can also consider the cost of each VM. Cost here, I am considering the monetary cost, as the monetary cost is pretty much proportional to the configuration of the VM. And as the cost increases, there is more liability or there is more need for VM to have fault tolerance. So in our approach, we have considered a combination of VM cost and number of faults that has already occurred in a host for identification of VMs to replicate. Proposed fault tolerance algorithm. It works by replicating a request allocated to a fault-prone VM, and also it implicitly covers the faults in a host. If a particular host failure occur, all the VM on that particular host will fail. Algorithm do so by considering fault probability of each VM based on the number of faults that have occurred in the host. So algorithm determines a rank of each VM which consider the cost and number of faults previously occurred. This VM rank is the main criteria for determining if the VM should be replicated or not. But if a VM is replicated for execution of a same task, we will only be accepting the result from the VM that has returned it first. And for the part where a VM which was not selected for replication, if any fault occurs in a fault manager or intermediary identify such VMs and resubmit it immediately so as to reduce overall turnaround time. Proposed algorithm has been simulated on CloudSim and CloudSim Plus. So CloudSim Plus is an extension of CloudSim which provides a module for introducing faults in VM. CloudSim and CloudSim Plus both are the Java-based classes and packages to simulate cloud environment behavior. In our simulation setup, we have considered VMs of identical configurations. So cost of all the VMs would be same, and we can replicate or replace the cost in the equation as 1 to give the simplicity. Threshold for identifying if a VM should be replicated or not has been taken as 1. So this brings additional simplicity for the simulation setup. The number of data center created is 1 and the ratio of processing capacity of host to processing capacity required by all VM has been kept to 75% so as to avoid any resource contention and delay due to the same. Simulation results have been obtained by running the simulation for different number of failed VMs which has been taken from 1 to 8. And result has been compared with the self-healing fault tolerance technique in cloud, one of the reference work. Result comparison with the proposed algorithm and self-healing work has been plotted. This plot of number of VMs failed and ratio of delay over total execution time has been plotted for this work self-healing, one of the reference work, and RP, which is this presented work. So we can see that as the number of VMs failures increases, delay over total execution time ratio for this presented work increases very slowly as compared to the self-healing approach. One another plot for results comparing the number of VM failed versus average delay over average execution time has been plotted. Similar to the previous plot, here also we can see that as the number of failed VM increases, average execution time, average delay time ratio increases very slowly for this work. Now this one more plot where we are comparing number of failed VMs versus execution over total execution time has been plotted for both the works, and here we can see that the proposed work simulate the similar behavior as proposed in the self-healing algorithm, and it is considered a good thing as the number of VMs have been increasing, failed VM are increasing, but still execution time or ratio of execution time per VM is comparatively or mostly the same. Thank you.